Hi, in this video I'm going to go over question 8.1.18 from the MyLab homework. It was question 14 on the fall 2021 8.1 homework on MyLab for statistics. The question reads, the test statistic of z equals 0.58 is obtained when testing a claim that p is greater than 0.19. This is a right-tailed test. Using a 0.1 significance level, complete parts A and B. First, we're asked to find the critical values, and then we are asked whether we should reject or fail to reject. The problem states that we have a right-tailed test. We know this is a right-tailed test because it says p is greater than 0.19. When we're looking to find our critical value, we're looking to find the value that has 0.10 to the right of it. So we're looking for z sub 0.10. There are two different ways that we can do this. We can use the inverse norm feature on our graphing calculator, as we learned in class in chapter 6, or we can use the standard normal distribution tables that are listed here. There's one for positive scores and one for negative scores. I'm going to go through with you how to do both ways, starting with the calculator method. When I have a normal curve and I have an area under the curve and I want to find the z-score associated with it, I use what's called inverse norm. And then I put my area, p, which is 0.1, my mean for the distribution, which is 0, because we're talking about the standard normal distribution, and my standard deviation, which is 1 in this case. And that area is going to be give us actually the symmetric value of negative 0.10 in most of our calculators, because a lot of us in our calculators don't have the option to go right or left. So because this is symmetrical, I'm going to put a negative sign in front of here. So let's take out our calculator. So we'll type into our calculator second vars, and then we'll select inverse norm, which is option 3. The area is 0.1. That's the shaded area under the curve that we see here. The mean is 0, and the standard deviation is 1. If you have a calculator that does not have a menu, you're going to put commas between these values, and the comma is listed above the number 7. Now, I mentioned before that when we put this in, the area generally is an area to the left, but my calculator has an option to go left, center, right. So I'm going to select right and then paste. If your calculator does not have this option, you're going to come out with the negative of the value that I have. Just make it positive because it's a symmetric distribution. So what we come up with is 1.28. Because we had a right-tailed test, we know that we only had one critical value. So you can select option B. And that one critical value we just calculated is 1.28. Now we have to determine, should we reject H0 or should we fail to reject H0? Now, what we're going to do is we're going to compare the test statistic z equals 0.58. Z equals 0.58 to our critical value of 1.28 that we just calculated. Now, if we have our test statistic falling in this green region here, we're going to reject. If we're not in the green region, we're going to fail to reject. So I'm going to take my number of 0.58 and plot it on the z-axis here. See our critical value of 1.28, we have 0 in the center, and 0.58 we'll say is about right here. You can see 0.58 falls towards the fail to reject region. So we're going to say that H0 should not be rejected since the test statistic is not in the critical region. So my answer choice is A, based on what I have here. We are only rejecting if our test statistic Z is greater than 1.28, that's when we reject, since this is a right-tailed test. If our z-value is less than 1.28, we're going to fail to reject. Now that's all for this problem. I hope you can use this as a model to complete similar problems. And if you still have questions, feel free to reach out to me. I'm here to help you. Have a nice day.